Good afternoon, everyone. Hope everyone had a good lunch. This is going to be track 3, and our next speaker is Craig Johnson. Craig Johnson serves as Technical Solution Architect with Forward Networks and is based in Irving, Texas. Presently, his work revolves around public and hybrid cloud architectures with a special emphasis on automation and security posture management. Before pivoting to public and cloud endeavors, Craig amassed extensive experience at Cisco, as well as various startups. Beyond his professional commitments, he is an active AWS community builder and spearheads the Texas NUG, the Dallas Networking Users Group. He also holds the distinction of being CCIE number 6965 with expertise in routing, switching, storage area networks, and data center networking. All right, everyone give it up for Craig.
Thanks much. Those CCIEs are expired, by the way, so don't worry about those. So what I want to talk today is about the experience I've had using Terraform over the past year and a half, and some new features that have come out with it that really do help with cloud posture management. So just as kind of an agenda, I assume you guys know what cloud security posture management is, but we'll cover that briefly. Talk about some of the challenges, why Terraform is the ideal tool for it, and we'll talk about exactly what that means, and then we'll go a little deeper into it. So it's not just slides here. Halfway through, I'm going to go back in there and start a demo, because I actually want to show you exactly how this works and how you can start using this today. And everything I'm showing you, my code is totally available on my GitHub. There'll be a link to it at the end, so you can do exactly what I'm doing inside your own environments. We'll talk about how we can integrate that into other workflows and automation, because I'll have just a few examples, but obviously, this is being an extensible framework. You can add as much as you want to with it. And then we'll have some resources and some links to everything I'm talking about, because no secrets here. So just as kind of an introduction or a reintroduction into what I mean by cloud security posture management. So the idea being is it's a continual approach that we want to make sure our configurations are correct. So I'm not talking about doing scanning. I'm not talking about looking for active threats. We're talking about making sure the config that I meant to put on there or my policy said that it should be actually is configured correctly. Because we find that most of the problems out there aren't necessarily because of, oh, someone discovered something novel. It was because there was a configuration either in the cloud, on-prem, on a host, anything there that was supposed to be correct, was not applied correctly, or the intent was not done correctly. So that's the focus of what we're talking about and how we can improve that in our environments. So, and the idea being is that, yeah, this is just way too complex for any one person to do. When you look at even just a small cloud environment, they sprawl out of control all the time. Even just a few VPCs, multiply into dozens, not even counting multiple accounts, and help you if you have multi-cloud configuration, having to manage that entire environment, and having to make sure that your posture is correct for whichever you want it to be. So some of the challenges that I see with it. It changes just way too much. I mean, my day job at Forward Networks, we do a lot of people helping with their inventory on the cloud. It will change by 20, 30% on a weekly basis in the number of resources you have, because it is so easy, and I'll show you when I do the Terraform demo, it's so easy to say, well, I'll just spin something up to do some testing, I'll keep it up for a while, and whoops, now I've got an open attack vector. And then next week I'll turn it off, and then, did someone get into it? I had a lateral attack in there? I don't know, because it just changes way too much. So we need a more continual nature, because it's not like on-prem and data center networking where things don't really change all that once, it takes you too much to get a VM, turned on. In the cloud, it's easy enough for me to turn it on, turn it off, turn it on, turn it off as much as I need to. The time for the manual checking is just over. We can't do it anymore. Things happen way too fast. We need to have the ability to do a more automated checks. And at this point, there just hasn't been a good way to really do this. There hasn't been a good, we've talked about automation for many, many years in networking. It's never really caught on in terms of a change control. Well, if we can at least do some baby steps to make sure what we have there, inside the process that we have, that things will go a lot better. And of course, things happen just way too fast. I'm not even talking about standard zero-day threats, but if I want to make some minor changes to my posture, things happen way too fast for me to do this on a manual basis. So why is Terraform the ideal tool for this? So quick show of hands, who here is familiar with Terraform? Who here has used Terraform? Awesome. So Terraform, if you're not super familiar, is what's called an infrastructure as code environment. So a little different than something like an Ansible, which is a configuration engine. Terraform is a way for me to identify and create a infrastructure environment. What I'm going to show you today happens to be in the cloud. What makes Terraform really cool is that you have all of these what are called providers, which let me define the environment that I want to. So it could be AWS, it could be Azure, could be GCP, could even be Kubernetes, could be vSphere, even some other ones, some vendors have their own providers for. So it's a way for me to define the infrastructure I want to declaratively, and then just let Terraform create it and manage it and put the policies that I want to in place. Well, it goes way beyond provisioning. So it started out as an awesome provisioning tool. And it's, if you're doing anything in the cloud, having one language that you can use for all of your cloud environments is a super easy way to do things, and it makes it very, very easy to manage, versus having the kind of the old way we did things in the data center, where someone logs in, configures it, did my config up to compliance, that sort of thing. The virtue of this infrastructure as code environment is that it aligns perfectly with what we're trying to do on posture management. Okay, so let me go walk back here, and I want to show you exactly what I mean by how I can use Terraform to create an environment, and I want you to see what I've done wrong, and on the next slide we'll go ahead and see if anyone can spot that. So this is my AWS environment. I'll just go ahead and open up the VPC console so you can see I don't really have anything defined here. So no VPC here listed. Yeah, VPC's none. So I'm going to go ahead and go to my VS Code here. Let's go ahead and increase the size a little bit. So this is my Terraform file. So what this is, this is the configuration file that I'm going to use to create this environment. So you can see a couple different things here. I've got the AWS provider here. I'm going to put what I'm doing in US West 2. Let's go ahead and put a private key, assign that private key inside AWS. The resource here tell me I'm going to create a VPC. I'm going to create an internet gateway. Route tables, put a default route on that route table, pointed to that internet gateway. So that's what I really like about Terraform, is I can define all of these blocks declaratively, and because these are all variables, I can assign those variables and refer one variable to the other, and Terraform will resolve all of those dependencies for me. Going down a little bit more, we've got some subnets, route table associations, and then a couple of instances I'm creating, and then of course, on those instances, I'm going to apply a security group. And then we're going to just output the public IP address of those instances. So all I have to do inside Terraform to make this is just apply it. So I'm going to type in Terraform plan, which is going to look at this main.tf file. And it's going to tell me what I'm going to apply here. So I'm going to apply all of these things. It has entries for the things I know about. Most of these are going to be known after apply because they're dynamic inside AWS. So it's just telling me my configuration file is correct. Nothing exists, which is why they're all plus signs here. So let's go ahead and apply that and see what happens. So it's going to do the exact same thing, except now I have a, do you want to perform these actions? It's going to perform what I did here. Yes or no? So let's say yes. So now Terraform is going to go out to my AWS environment and create all of those things that I just asked it to create. So you can see it's creating the instances up above here. It created the internet gateway, the VPC. And if I go over to my AWS console, you can see, yep, it's created that VPC right there. And if I go into the actual instances, Some of them are just up and running, but they're kind of getting there. So it takes a few minutes or a few seconds for these to instantiate. But you can see over here, it's finishing creating. It takes a few seconds for it to complete. Azure takes a little longer, but AWS is usually pretty quick to instantiate these resources. So after this is almost finished, you will see, yep, it's finished, apply complete. I created 17 resources. Here are the public addresses of what I've created. And of course, there's a private key. So this is kind of a snippet of what I had here. So from a security perspective, what do you think, anyone can answer, is a problem with this setup? Sure, go ahead. SSH is open everywhere. So if you look on the right, I have that security group. So that security group lets me get into the instances I created. That security group is applied to my instances, and you can see the rules I have set up. I'm allowing 22 from anywhere. I'm allowing ICMP from anywhere, and egress I'm allowing anywhere. Now this is a super, super common configuration that people do. When I'm just trying to get something up and running, I need access to the internet so I can get into this device and actually make my configurations to it. But this is not something you should ever have in production because anyone on the public internet can now get to any one of these instances. Well, how can I make sure inside Terraform that this kind of thing doesn't happen? So this is kind of what I mean is, these kind of limitations that we have you can overlook such a minor configuration on many of these things, and you're going to have all sorts of these vulnerabilities. SSH is just kind of one example of it, but you can take it to, lots of different levels. Oh, sorry. Now, this was a really, really small Terraform environment, but as I grow my infrastructure, trying to manually check these things isn't going to work out for anybody. And I want to make sure that I'm consistent all of the time inside this environment. Now, these checks that I'm going to show you, they can be done very rapidly, and I can do this in a very, very quick feedback loop. Now, what I'm going to show you also is, this is just Terraform itself, but this can also be part of a much, much broader framework. So, there is a feature that came out earlier this year in Terraform 1.5 called check blocks. What check blocks do is they let me put inside Terraform a way to check the configuration to make sure that, yes, the configuration is valid and I can apply it, but I have more policy-specific checks that I want to put in. So let's take a look and see exactly how something like that would work. So I'm going to go over here to my other tab, and I've got an example of a Terraform check block. Now, we correctly identified that we have SSH open from the internet, and anyone can get to it. So I want to make sure that we check for that condition. So I'm just going to copy this little bit of code. So you can see here I've got a locals block. I'm checking for unrestricted SSH. So it says for rule in my AWS security groups. Check to see if I have port 22 open to and from anywhere to 0.0.0.0/0. And then do that check. I have an assert. If that check is true, basically if that entry exists anywhere in any security group, print out a warning message that says, hey, SSH is allowed from anywhere. You probably don't want to do that. So let's just go ahead and copy that block and put that in my Terraform file over here. You just stick it anywhere. And now I'm going to apply this again and see what happens. So no real change in the state here, but it's still got everything I have in there. But look what I've got now. Warning, check block assertion failed. Now, I have something that in my infrastructure that now checks for this specific condition. So anytime, if it's in your own Terraform or something that someone else applied, you can check the configuration of anything that you want to say, hey, in this case, yeah, it's certainly valid to apply 0.0.0/0 to an SSH, but you really don't want to. And in this case, I'm just putting a warning, but I could turn on inside Terraform to make that an actual fail condition so that you wouldn't be allowed to do it. Well, what else can we do with this kind of feature? Well, I can take it even further than that and not just look at configuration here, but I can do something a little more even on the data plane side. What do I mean by that? Well, if I go back over here, I'm going to have an additional check here that is going to execute an external Python script that I have. This Python script is pretty simple. Oops. All it does is just ping whatever I have it said, and basically tell me from my workstation here if I can get to whatever I'm pinging to. I'm going to pass a variable to this Python script that will see if I'm able to ping. So if the variable I pass here is able to ping, I'm going to print out an error message that, hey, this is reachable from the internet. You've got something else wrong. Now I have direct reachability from this VM to the internet. So just a simple example of the Python script that I have here. So let's go ahead and take that and put that in our Terraform script. So I have an additional check assertion block failed that says that VM is reachable from the internet because it's there. Now the great thing about this one is the first example that I showed you was more of a check looking at just the configuration. This type of check will now look at something on the data plane side. Like I'm actually pinging that device to see if I can get into it. So this can be a post-configuration check, because if I were to have this beforehand, obviously the VM's not up yet. But if the VM is up at any time, now you can check for these sorts of things. So in this case, it's a ping, but it could be an SSH, telnet, whatever kind of you want to look at for. So what else can we do with this? Well, I can ensure that the VMs that I have do or do not have public IP addresses, because in some cases I don't want them to have IP addresses if they are supposed to be internal. And if someone mistakenly assigned us elastic IP, I want to know about that. I can restrict SSH access. I can enforce developers and anyone creating a VM to say, no, you can't allow SSH from 0.0.0/0. I can make sure that they apply it to a particular CIDR or a block, or even something smaller than that. I can make sure that they have the correct protocols in place. So I can make sure, so this is just one example here where I said, yeah, just look at the SSH, but I can make sure anything inside AWS I want to check for. Make sure they have TLS 1.3 apply. Make sure they have the right encryption on any of their keys. Anything I want to check for that still might be valid in AWS, but by policy I want to make sure is in there. And I can make sure that my resources are not overly exposed. Like in the example I showed you, full access directly from the internet, anybody can SSH to it. With this, I can tone this back down. So here's just kind of what I showed you before. With these kind of rules here, now I have the ability to say, yep, SSH is allowed, and that security group has that there. So the external script is just an example here. So when you see you'll see this on my code if you want to go ahead and look at that as well, but you'll be able to see this here too. So how can we extend this even further? Because these are really simple examples, checking for SSH, pinging. How can we do this even further? Well, I can do a whole sorts of other checks. You can look at all sorts of different configuration. I can make sure my scripts are correct. I can even call Ansible's playbooks from this to do other checking. Like say I'm configuring an actual device in my cloud, like maybe I've got a Palo Alto firewall or something like that. That's gonna require a configuration. I can make sure that I have that as well. I can do those external scripts, but I can also call external APIs. So the benefit of that is maybe you don't have the tooling. Maybe you don't, maybe you're relying on an external partner, like a Wiz or someone like that to actually do your posture management. You can integrate this directly with these check blocks to say, hey, query their API that will look at my environment and then give me a pass-fail on it. So this way you're not relying on them after the fact to do this. This is integrated in with your deployment process. So the benefits of that, of course, it's going to be early detection. You're going to be able to continually do compliance on this, and you'll be able to remediate this right away. So I want to go ahead and pause here for a second and kind of give you some of the key takeaways of what I've talked about here. So the idea behind this posture management, it's something that we've relied on external suppliers and vendors to kind of help us out with. We go to others, hey, look at my environment and make sure it's secure. You need to be able to have this continually checked inside your own environment, no matter what it happens to be. We want to be able to automate the entire environment. Now, if you've already been using Terraform, you're already on board with this, but the idea being is that now we can have this in a much more automated fashion. The checks that we can do, I've only scratched the surface on. Like a company I work for, Forward Networks, we do intent checking. We can have those kind of APIs to say, query us to do an API to say, give me a pass-fail of does the intent work or not. And I'm not doing this, after the fact or relying on somebody to do this. I'm having this inside my change window process so that I can have continual compliance directly in the change window. So I know that if the change was successful, it did exactly what I managed to do. And not even just successful, am I opened up to any kind of security vulnerability? The idea of why we're doing this is we're all going to make mistakes. Not just in creating the files and making sure that they're constructed correctly, but we're going to make mistakes where the errors that we have are going to compound more and more, and they're just inevitable inside this environment. And the idea behind this is just one tool in the toolbox. When you expand this out to your entire DevOps environment, like I mentioned, external tools, whether you have a CI/CD pipeline that pushes into this is something that can be done, completely all the way. And of course, continuous improvement, continual correction. As new 0 days, as new threats come up, you can add new checks, you can add new environments to take a look at this. So here's some of the resources that I want to show you here. So the 1.5 checks is right there, Terraform.io language checks. So you can start integrating this into your environment here. We also have those external tools. If you don't know how to use Ansible with Terraform, that's actually new in 1.5 as well. We used to have to use an external hook for it. Now Ansible has an actual provider for it, so you can call it directly from there. So I want to leave you with a couple of links here. So all of the code that I showed you here is on the left there. That's my GitHub. My personal website's on the left. And as mentioned before, I lead the North Texas USNUA chapter. So if you're in Dallas next week, I invite you to come on out with that link right there. Free beer, and it's a fun time. We have a speaker, we have a panel, so it's a great time for everyone to have. So I want to go ahead and pause there. Is there any questions on Terraform itself, Terraform check blocks, the environment, posture management, and see if there's anyone anything to answer?
So regarding posture management, what is Terraform able to do that can't be done with config and CloudWatch and Security Hub and those kind of services?
So you're right, Terraform doesn't do anything that those other tools can do. What the benefit of Terraform does here is that it's a uniform language that works across my entire multi-cloud environment and plus everything on-prem. So I don't have to have multiple tools. Everyone has been talking about doing a multi-cloud environment, which I understand. There's good reasons for that. But it also means you have to have separate tooling for every cloud that you do. You use something like Terraform, and current licensing issues notwithstanding, there's already a fork on that so that you can use the open source version. It's a way for you to have the same sets of tooling across your entire environment. Any other questions? Okay, excellent. Well, I'll be up here for a bit, so if you have anything else, if you want to, kind of see the demo again, if you want to see exactly when you was, I'm happy to answer any questions offline. Appreciate it. Thank you, everyone.